Good evening, friends. Welcome to Eastern Academy. And we are today going to discuss about controller programming. This is a very tricky topic. And this is the most important topic in the embedded system programming. And today is a session 1. And let us discuss about the, first of all, introduction to what is controllers. Before doing a controller programming, what is controllers? That will give you a lot more insight to you when you go into the controller programming. Okay. So let's go to the board and we'll try to understand that. What is that? Okay, so let us see, we learn in the school addition, subtraction, multiplication, then division. Am I right? We learned these 4 operations. We know that. Everybody learned this addition. But I have a big question. To use a calculator, do you have to know these operations? These two are same. I'm going to do everything. But to operate a calculator, do I have to know how to add or how to multiply, how to divide? No. Am I right? It's a big no. A big no. I do not have to know anything. I've seen people, the shops. Am I right? If you go to all vegetable shops, fruit shops, grocery shops, everywhere, people use the calculator nowadays. Am I right? They do business of lakhs and crores, but they don't know this. They don't know how to multiply the numbers. If you give them 756 multiplied by 6, 44, 33, they cannot multiply, but they use calculator. Am I right? Understand this? Also, I have a driver. Do I have to know driving to tell the driver to drive the car from Chennai to Bangalore? This I have to tell my driver. To instruct my driver, take me to Chennai and Bangalore, do I have to know driving? No, a big no. Understand? This is a concept. To tell my cook, hey, I need today aloo paratha and sabji, whatever items. I tell the cook, do you have to know cooking? No. This may looks to be a very simple one, what I'm discussing, but this is a reality. If you understand the reality, you will do a wonderful embedded system programmer. Understand that. Then you may be having a doubt. To using a calculator, I do not have to know about addition, multiplication, subtraction, division. Then why in school we are being taught all these things? Why? Why not from the day 1? The school, they teach you how to use calculator. Am I right? Anybody have an answer? Why they teach you in the school, instead of teaching you how to use calculator, they teach you all these operations. They are actually wasting about how many years? 2 to 3 years. And also, you know that in the school exams, they don't allow you to use calculator. Why? Yes, you have to know the basic understanding. That is correct, but this is mistake. In exams, you should be allowed to use calculator. It's available today. It was not there in those days. You memorize the tables, you did everything, waste the time. Today you are not. Actually, my daughter and son were studying in the Cambridge education. There, calculators are allowed everything. It does even a bigger operations. It does the statistical operation. Everything is doing. Even that calculators are allowed in the exam, but you cannot solve the problem. So today, what you need is a problem-solving approach. So how it's exactly related to us, that is most important, because the last 2 sessions we discussed about in embedded programming sessions, we discussed about how to connect a LED, how to connect a 7 segment, single or multiple segments, how to connect a dot matrix display, how to connect a switch, how to connect the switch, or how to connect a keypad. We have discussed all of them. We have directly writing a program, CAD start, out, or CAD star in. Using that, we say out is equal to some address. In is equal to some address. That based on the microcontroller, what you are using. Whatever it is. And you put star out is equal to something, you directly control. See that? So if you out here 0B 100 100 those pins will get 5 volt and those digits will be on. We have seen that. Am I right? This is called like learning, addition, subtraction, multiplication, division. This gives you the concept. This gives you the concept. But in your real life, come to the real life, come out of college, come to the real life, either in the office or at the workplace or your own company, wherever it is, you never multiply, you use calculator. Am I right? You use only calculator. Like that here. There's a trick here. That is what we are going to discuss today. Today's topic is only about that. Okay, so we understand how to use calculator. That's very important. The person now who uses the calculator effectively becomes scoring more marks than if they allow you to use the calculator in the exam hall. Think about it. In the exam hall, if they allow you to use the calculator, the person who knows how to use calculator and better calculator will score more marks. For example, I have 2 calculators, calculator 1 and calculator 2. In this calculator, I can do only addition, subtraction, multiplication, and division. In this calculator, I can do all these things. Plus, I can do square root. I can do square. I can do average. I can do 1 by x. Let us assume that I can do all these operations. So, if they allow you to use a calculator in the exam, the guy who uses this calculator 1 and calculator 2, if they ask you to find the average of so many numbers, then you have to add everything and you have to do multiplication. If they ask you to do square root of 25, square root of some 78, then you have to find a mechanism. But if I use calculator 2, I will do it immediately. So please, there's a big difference. This is what you need to understand to be a successful embedded system programmer. Please understand. If you don't understand these techniques, that is what the problem with our whole engineers. I'll give you a small story. Yes, the story will give you the good idea about this. There are two, most of you may be knowing the story. There are two people went to the forest, friends. Okay, they were cutting the trees. They use axe. Okay. One guy was doing from morning to evening. That guy could cut about only some 2-3 trees. Then somebody took a rest every 1 hour. That guy came out to be about 6-7 trees. The reason was the first guy was continuously doing that. His axe was not sharpening. The sharpening is gone. The other guy was sharpening his axe, so he could be able to cut more trees. That is what today you are. Exactly your position is you do not sharpening your saw. That's very important. Now and then you have to sharpen your saw. That means that's very simple. You need to understand the latest technology. What is the industry wants? These informations, normally without knowing that, you suddenly jump into the water. Let us assume that this is all the information you should know. If you go to the beach, and I'm telling you that from here you're 10 kilometers or 5 kilometers, there is a small island. Okay, you go there. Assuming that you know swimming. After about 2-3 kilometers in the sea, there's an island. And I want you to go there. But you don't know which direction it is there. All right. You don't know which direction it is there. So if you start swimming, suddenly get into the water and start swimming, then you don't find it. It will take very long time. At the same time, you climb on the lighthouse and find out that which direction that island is there. Then get into the thing and start swimming the direction. You put your effort. We are not telling you don't put the hard work. Hard work, nothing can replace hard work. But at the same time, you have to know that your direction is very important. You understand now? What you are doing, most of you people are all just jumping into the sea without knowing the direction. So what you do here is, you people, you see, your lifetime is only so much.
Sir, your voice is not audible. Voice is not audible.
Okay, so the thing is that we are trying to move towards the direction of the sea. Everybody is going towards the island, but somebody who is going towards this direction gets success. For others, go and come back, and then next time you can try become success. You success on second attempt. Somebody go and come back and go to the third attempt. So to reach the island, that is what your success. No, this is required now. Otherwise, normally I don't think this type of things. That's not my ball game also. The trick here is you need to know now exactly where embedded system is going so fast. It's changing every day. Every day that embedded system is changing. So better we need to know that where we are in embedded system. That's a trick. Do you agree that? That is, we normally thought initial days when you use a LED on, that is what embedded system. Then people thought you start using a controller, that is embedded system. Later, they thought you are using a functions embedded system. Today, they are saying that you use the operating system, it become embedded system. The things are changing. The basic requirements are changing. So don't get confused on the thing. So learn these things. That is what I discussed. Switch, LED, all these things you learn it. But that doesn't mean that you need to do practice only that. Don't take too much of time on this. Keypad dot practice. Okay. Is it clear?
Yes, sir. Yes, sir.
Okay. I think let me yeah, sometime my voice. Okay. I hope I'm clear. My voice is clear. Okay. I don't want to have a.
Yes, sir.
Okay, that's fine. So now what we are going to discuss is there is a trick here. There is a component we use in system electronics. Like almost like this itself is electronics. You give an input, it gives you the output. A small component, like a driver. This component, you don't worry what is inside. It's basically electronic component. I could design this with either hardware or AC. I can design this with a AC. This is an IC or FPGA, or this could be a microcontroller. I could use any of them. This component can be created any of the method because this functionality is fixed. Not like your general microcontroller. Your general microcontroller, you write a software inside the ROM. The functionality of the microcontroller is changeable by the programmer. Understand this is. So I may be using the microcontroller here. See that? See the difference. I may be using the microcontroller at both the places. Whereas in this case, you cannot change the content of ROM. Of course, this is not only microcontroller. Not only micro, it can be even a ASIC or a FPGA. Please understand. This can be anything. This component. This component is called controller. There's a big difference between microcontroller and controller. Understand?
Sir, FPGA and microcontroller both are different now, sir.
No, I can build the, see, a microcontroller is a functionality, top level. I can build the microcontroller with using FPGA. Understand? FPGA is a hardware. Understand? Microcontroller is, see, please understand, that's good. These are things I thought I'd spend this time and understand. We should not get confused. See like this. What is microcontroller? It has the microprocessor, which has a ROM, which has a RAM, which has a controller. That's it. Now, what is RAM? The RAM is nothing but, as we discussed in the digital electronics class, it is nothing but a combination logic to select the particular line, a sequential logic to store, and a tri-state logic to read. We use all of them. What is combination logic? It is nothing but gates. What is sequential logic? Nothing but gates. Understood? So, what is inside the microprocessor is nothing but gates. So, what we do here is like this. Please understand what you did in the college is we use the gates to design the circuits. We use the gates to design the circuits in the college. So we use a breadboard. We use the gates 7408, which is the AND gate. 7432 is the OR gate. 7404. We use the thing. So whatever, we will connect this pin, take the wire, and take this to here. This is what we do it on the breadboard. Now, what we did was the same connection was given inside the IC. 4 inputs, 1 output. This is called ASIC. This is called ASIC, where the manufacturer put this IC and give it to you. Now, FPGA is nothing but I have lot of gates inside. I have lot of gates inside. Understand? So many gates which are not connected. They give you the gates with no connection. But they given a small logic here called configure logic, config logic, config block. Now, from your laptop, you communicate through this guy, you can make the connections. This is what called FPGA. Understand? The difference between ASIC and FPGA is the same connection is fixed. You cannot change it. That's why it's called application specific IC. You cannot change the connection.
So
But
we can't
here-
program ASIC, right?
No. No, you can
Okay,
program. See, don't get confused. Programming is different and changing the circuit is different. Your microprocessor, microcontroller is a ASIC. Microcontroller is a ASIC. I connect the gates inside, but I cannot change the connection. Do you understand? I cannot change the connections inside the microcontroller. But that chip will behave only that way. For example, there is a chip. That chip will behave only this way, microcontroller. Whereas in FPGA, for example, let me tell you much clarity. Let me give you much clarity. I have a microcontroller 8051. I have another microcontroller called ARM. Let us assume that STM32F103. And I have another microcontroller called Atmega 2560. Assuming that I have 3 microcontrollers. Understand now? If I buy this from the market, STM32F103, that will behave only as a STM32F103. That functionality cannot be changed to 8051. Whereas I buy a 8051, 8051 will be only 8051. I cannot change it. If I buy the Atmega 2560, that will behave only as a 2560. I cannot change the functionality, property, or any of these things because already they are connected inside. So that's why we call them as a ASIC. These are all called ASIC. But if I have a FPGA, think here. If I buy a FPGA, Xilinx FPGA, Spartan, whatever series, now by developing a Verilog code here, I can make a Verilog code as 8051. If you download it to this guy, I make the connections, this FPGA will become 8051. Now, I modify this to Atmega 2560 and download it there. It will become Atmega 2560. If I write a Verilog code called STM32F103, I downloaded that. This Xilinx become, see that. So, whatever you are downloading the bit file, we call connection file, bit file, generated by your synthesis process. The FPGA, so a FPGA can be any of the ICs. 103. Now you understand. That is so, I cannot convert these ICs.
Yes, sir. Now got it, sir. Clear. Thank you.
But the advantage, then why, when the FPGA can be any IC, why I have to buy that? FPGA is very inefficient. There'll be lots and lots of gates. You use only that few for 8051. So FPGA will take more power, costly. But whereas when I make a ASIC, if you take STM, I will use only the gates wanted by the thing. So it becomes small. It becomes very power efficient. It becomes cheap. But only problem is I have to manufacture in bulk. I can buy one FPGA, but I cannot buy one of this. This means it becomes very expensive. I cannot ask the manufacturer to manufacture only one. That's why I'm telling people, ask the Quora, can I design my own microprocessor? You can design today. You can design your own microprocessor and download it onto the Xilinx. It's possible. You understand that? You can make your own microprocessor, own instruction set. You can design your own compiler, everything. This is supposed to be the project in the colleges. So please understand, I buy a IC which does a specific job. That can be a ASIC, or it by a specific job. We'll discuss about what is a specific job. That can be the FPGA, or it can do a specific job. It can be a microcontroller. Since it is doing a specific job, we call all of them as controller. So FPGA is not a controller, please. FPGA can be used for any purpose. FPGA is a field programmable gate array. It has free of gates which you can use. I can build a FPGA microcontroller. I buy a FPGA. I have a FPGA. I write a Verilog code. I download it. I can convert this to the 8051 microcontroller. It will behave same like you buy a 8051 chip. The market, you buy a 8051 chip. I can do the same thing here. The market, you buy a 8085 IC. I can do the same thing here, 8085. Understand? So FPGA is the hardware. I can use it as I wish. Whereas controller or microcontroller or functionality. Don't get confused between the hardware and functionality. The controller, microcontroller functionalities. Whereas FPGA is the bottom level gates. This guy had millions of gates which are not connected. They give you the hardware with you. I can use this to do anything. So the trick is that I don't need controller, I don't need microcontroller. I can do everything on the hardware itself. There are something, let us say I want to multiply two numbers, 32-bit numbers. Okay, I can do the multiplication using only hardware. I can use it only hardware connections, no programming. Then that is called multiplier. This is called multiplier. So understand, don't get confused. See, the trick is that you have to go back to the college. The college, you draw the circuit. Let us take the thing XR. Let us take a XR. XR is nothing but Y, X and Y, sorry, AB. So you draw the table A, B and Y. 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0. So these two are 1. You write the equation Y is equal to A bar B plus AB bar. Now you have written the equation. Then what you will do? Then you will go take the breadboard and you need to have a bar and multiply B. So you need to have what? 1, 2 NOT gates. Then I need 2 AND gates. I need one addition. I need one OR gate. So this is 7408. This is 7404, 08, 7432. So we plug the ICs with the breadboard. We take the two inputs A and B. This is 7404, 7408, 7432. So what happened? We will connect from here. I want A bar. I take here input inside the gate. I'll take the bar and connect it to the AND gate of this guy. You are right. Then I take one more wire here and connect it here. So this become A bar B. So this is the way things are happening. You make the connections on the chips. You get all these gates separately and you make the connection. Now this XOR can be built inside your FPGA. You can download the equation here. There will be a logic called conflict logic, which will take the thing and give it to you. That is what who are learning, that VLSI people are learning. The VLSI people are learning only this. How do I make the IC with a particular functionality? So your microcontroller or microprocessor or controllers are made using FPGA or AC. That is what why I'm discussing this, because nowadays all the embedded system products, the big companies, they have a FPGA. Why? It's because some functionalities are not available in my microcontroller. I want to put the functionality outside. I cannot use gates. It takes very big space. So they download it inside the FPGA. The microcontroller will talk to the FPGA and you get the outputs. So nowadays, knowing the knowledge of FPGA, not creating, knowing the knowledge of FPGA is little bit required by the embedded people also. So don't get confused between FPGA and the controller. I can build the controller using so many things. You can using ASIC or FPGA or microcontroller itself. I can make the controller. I'll tell you now. I'm not going joking. I'm going to explain to you this one in about few minutes. So, do you have an idea? Got an idea about what is microcontroller? What is controller? Controller is nothing but that's the specific job. It is fixed job. Specific job. But that means that he is a driver. Now the driver has only one thing. He accepts the input, not the functionality. Functionality is fixed. Functionality is fixed. You cannot change it. But you can change. I can tell him that, hey, drive me from Chennai to Bangalore, or Bangalore to Hyderabad, or Delhi to Agra. Am I right? These things you can tell him, and he will do the operation. But you cannot convert a driver to the cook. That is not possible. Understand? Whereas in the case of microcontroller, I can make the microcontroller to control as a LCD controller or display controller. By making a different program, by writing a different program, I can convert the microcontroller to any functionality what I want. Please understand this. A microcontroller is a very generic. I can make use of for any functionality. Whereas, see, think of it. All rectangles, all squares or rectangles. Do you agree? All squares or rectangles. But the other is not true. All rectangles are not squares, please. If you see a definition of rectangle, opposite sides should be equal and the angle should be perpendicular. Here also same thing, opposites are equal. But the unique thing is all the four sides are equal. That is what square. But a square is also a rectangle like that. The controller, if you use the microcontroller as a controller, then I have a ROM inside which does the specific function. I cannot change it. But the code will accept the input and do the outputs. That we are going to, we will discuss about the next session about how is that. So please understand the things are changing in the world. There's a big change in the world's the way the embedded world works. It does not now, you need not have to know that how to control the LED, how to control the 7 segment, how to control the timer. You do not have to know everything. You can directly get into the controlling all of them using the controller. I need not have to know about the driving. I just hire a driver and drive my car. I do not have to know the driving. You understand that? But then why they have to know, want to know the thing? The companies are very careful, but sometimes they want you to know that how to control the devices which are not connected to controller directly with the microcontroller. Also, every day some new controllers are coming, and you should have the ability to understand that. That's why the companies say that if you have a fundamental knowledge, then you can able to use any controller. Ultimately, 99% of the embedded programming is using controllers, not your direct. That is maybe about 1%, which I discussed with you, all those LED, switch, 7 segment, dot matrix, and keypad, everything. This is only 1%. In your life, you're going to use 99% using only controllers. You'll be surprised. Then you'll be asking me that why I have to, why I've discussed, why I have to do all this programming. That you only gave the answer. I asked you the same question. When I have a calculator, why should I learn? Why the colleges teach you, schools teach you addition, subtraction, multiplication, division, and other operation? Why they teach you? That same, if you have an answer for that, the same answer for here also. Just because we don't use it, that doesn't mean that we should not. We should know that as an embedded engineer, you should know that how the basic microcontroller is working. But if you think that this is what the end, see that what is your problem is you so immersed and so much of get into the details. Most of the people, I've seen that 99% of the ECE is how much? It's a very, very big thing. 99% of the ECE students think this is called embedded system programming. They stop here. They lifelong they struggle to this. It's a very surprise. Am I right? LED switch, 7 segment, you have to learn it and go fast. But go and start learning the controllers. And the beauty is these two are totally different. They are totally different. Please. Here you should know how to drive a car. Here you should be able to tell the driver how to drive a car. So where to go. That's it. Both are not same. I do not have to know that how the driver knows driving and everything. I didn't teach him. I didn't teach him. Why should I teach him? He knows. He came to me. I'm paying him 20,000 rupees a month salary. Like that. Somebody is giving me the controller. I buy a controller. Let's assume that a small controller. We have a controller called RTC, real-time clock. I ask him that what is the time now. He will tell me the correct time, like a clock. Even if you power down the system, you power up. This game will have a battery backup, which I don't bother. I don't bother. This game is having a battery backup. That game will be running even when the whole, for example, your laptop, your computer, all the things. your mobile phone, everything is off. This guy will be running always. Who? This RTC. Because he counts the real time. So whenever you switch on next time, you will be getting the time from him. Then you will know that everything is fine. Understand? Correct. That is, you are perfectly right. That is what I'm telling. Anybody can move it here. See, somebody is having on 5 years experience on this LED switch, everything. This is zero because there is only 1%. No company bothered about this. Understand now? You should know how to use. See, I know this. I spent all my 5 years on this. I spent only 1 month on this. Your expertise is considered you 1 month. You spend 1 month on this. You spend 5 years on this. You're great, man. You understand? Because see, the companies are not running to teach you electronics or no. They are trying to make money. They are trying to. Let's say that if I give you some work, let us take a very in this session I give you lots of realistic examples because that is very important. Not many people understand this because the people those who understand make big money. That is the most important case I'm trying to tell you. Okay, if a company is telling you that you have to develop the software at the same time, you have to be in Bangalore tomorrow morning. Am I right? You have to develop the software. It takes about 8 hours, and you have to develop the software. Some presentation. You have to develop some presentation, and you also have to be at Bangalore tomorrow morning for the meeting with some top officials. You have only 8 hours. Am I right? They have told night 10 o'clock. Tomorrow morning 6 o'clock you have to reach Bangalore from Chennai. You take your car. You start driving. You reach morning 6 o'clock to Bangalore, to your head office, and you don't because you drive the car. You do the car. You don't have a presentation with you. Then your manager will ask you, or your higher office director will ask you, "Hey, are you joking? Can't you hire a taxi and then come and while coming in the car, can you do that?" This is a very simple question. Your director will ask, "No, sir, I thought I will save the money for the company." He said, "What save the money, man? Did they ask you to save the money? For coming to Bangalore to Chennai, how much is going to cost? 10,000 bucks? I reimburse it, but your presentation is one which is going to give a $1 million order to the company." Now you understand the difference. What you are doing right now is the mindset. The mindset is you are trying to think everything as so detailed. You have the resource available to do the job, and you have the money available to do the job. Now you will be asking sometime why some people from IIM or IITs are recruited for a 1 crore package. That is what these people are doing. Is simple. They are, because of them, company is going to get a cash. You always thinking of how to solve a Karnaugh map or how to solve this LED problem, 7-second problem. That is not the way today you need to solve the electronics. Today, embedded system is not to solve the problem by yourself. Outsource. The outsourcing is called controllers. Buy a right controller. Buy a right controller and start doing it. You have to go into every IC, buy it, see the ICs. Which IC is having more controllers inside? That is, for example, let me show you a small, let me share you the data sheet. Then you will know that what is the this controller thing. You'll be very surprised to know these things. Sometimes shocking also. Okay. I'm telling you everything and finally I say that this is not very useful, but that's the reality. Okay. Let's say when a customer is there, think of a minute. When a customer is there and he is buying the items, you start multiplying on the paper. Okay, that you use a calculator. Which one customer like? Customer does not bother your mathematics knowledge. What customer want? How quick you are going to give him the money and send him out items. That's a trick. Let me see here. If I show you that the simple controller, then you will know that. Which already we have discussed, but once again, I'm giving you the ideas more and more. Because I want you to understand very thoroughly before getting into the system. Understand it very thoroughly. See here. Let's take this chip. One of the smallest chip in the ARM. Very cheap. Very, very cheap one. This is one of the very cheapest ARM chip. Very low end, very, very low end. Cortex M3. Understand? Now, if you go into the details of this chip, is it visible? Your thing is, I think it should be visible to you.
Yes, sir, it is visible.
Now you see here, this guy, see that what they talk, the talk itself, what they are talking. Medium density performance line, ARM based 32-bit. With 64 or 128 KB flash, USB controller, CAN controller, 7 timers, they are controllers, 2 analog to digital controllers, 9 communication controllers. See what are inside. You come inside, then you will know. You see this, that's all, whenever you touch IC. See the huge man, the requirement for the demand for you is today too high. Now you see bottom. See here. This is what you have to see. See, this block of our controllers, man. You see that? Timer. We are going to discuss. Next week, next class, we are going to discuss. And UART. It's called communication. And SPI, another communication. I2C, CAN, USB, ADC. See? Temperature sensor. This is the one what we discussed in the last class. The last session, the 8th session, we discussed about GPIO. You just put the pointer and send the data out, it comes here. Okay, these pins are you are controlling directly and controlling that. But to control these pins, you need to go via these controllers. They do that. For example, here, they have a built-in RTC also. See, there's a battery backup. Am I right? This is the way things are working. So understand that. So please, for example, I put you another chip. I'll give you another chip. Let me get to another chip. Then you will know the difference. Because we're going to spend all our time on the learning controllers. I'll give you one more shock next week. That's all shock by shocks. Don't worry about that. Yes, you should. You should know the reality. See this. This is another chip. You can see the year of manufacturing. That's also good. You can see the year of manufacturing. When this chip was manufactured. The top page, they will tell you the thing. See, August 2015, this chip was manufactured. And this information is found product in full production. Right now, it's a full production. This product. It's available. See this chip, 103. It's a Cortex M3 based. Understand? It's a Cortex M3 based. See here. It's ARM core running at 72 megahertz. Whereas now, next one, 407. See that? This guy is Cortex M4 based. Okay. Running at it's having how many flash? 1 MB flash. And it has a USB with a OTG host. It can be USB host or slave. And it's having a Ethernet. And 17 timers. And it has a camera interface. Go down. You go down this one. The block. Then you will know that how big the block diagram is. But this is availability for 2,000 rupees, the whole controller board itself, not the chip. If you invest 2,000 rupees, you will learn everything of this, all these things. See here. See here the block diagram. See here. How many things are there? RTC is there, real-time clock. And they have timers. They have a UARTs, SPI, I2C, CAN, 2 CAN bus controllers, and ADC, supply sensors, all same. But they have a more here, PWM, to control the motors. And that we will discuss when we discuss the timer. I will discuss about the motor and PWM. We're going to discuss about all of them. Nothing is left. May not be Ethernet here. Is that available? Ethernet will be in the top one. Yeah, that's called high speed bus. This Ethernet and thing. We want to discuss about DMA, and it's running at 168 megahertz high speed. So do you understand now what is the system? That is, how many ports are there? Okay, so don't get confused. Why I am telling you is that you are going to, if you learn one timer, it's equal to learning all the 17 timers. If you're learning one UART, it becomes having all the UARTs. If you're learning one SPI, it's having all the SPI. If you're learning one I2C, it's enough. Let's understand. If you put them in a very top level category, things are very simple. That's it. That is what the job which I'm doing now. Now I am trying to explain to you that how you should get into the next level. Don't get bogged into but at the same time, without understanding the switch, LED and everything, if you come back, that is not good. Am I right? That is not good. Okay? Is it clear? So we have to have a both. That is, I wish you to use calculator. At the same time, you have to know addition, subtraction, multiplication, division. But if you spend up to 10th only doing the subtraction without using calculator, that is wrong. Because you should know how to use the calculator very fast. So you'll be spending the time on more useful time on something else, not only on the simple calculation. See, because this is not the college, this is the industry. Your time is money. Your time is money. The guy who does things faster gets better promotion. The guy who comes out with a plan to effectively use the hardware systems get big, what do you call it? Reward, bonus. Understand? And later you can have your own product, whatever it is. You can be your own entrepreneur. Doesn't matter. But please understand, this is all very, very tricky one. Okay, so let me take a break with this. Then I'll explain to you a small sample controller. Before we go into the ready-made available controller, let us build a small controller and do that, how it is working. So then you will be able to understand what the controller is. Because if you take readily available controller, they are for products. They are for products. You will confuse. It will confuse you. Nobody makes a microcontroller for teaching or learning. They make the microcontroller for products. So they will put as much complex things inside, such a way that people can buy it. They want to put all the functionality such a way that people will buy it and make a products. But we will discuss on the next session a sample microcontroller. Then you will understand that how we are doing that. Okay. If you have any doubt, you can ask me. Otherwise, I'll take about 5 minutes break before we discuss about a sample controller. We will decide. Before we get into the controllers in the next class, next session, we will discuss about our own sample controller. Then you will know that. Yeah.
Sir, just now you showed us that ARM microcontroller, right?
Correct, yeah.
So, sir, using that ARM microcontroller, what exactly embedded engineer will do, sir?
No, what
it is already designed by some other team, no, sir?
No, controller is designed, but the product, you have to design a product. You take the input from so many sensors. You have, see, in your agriculture field, if at night 12 o'clock, if there's a power goes, okay, if there is no, let's say in your apartment, if there is no water in the ground, then the motor is running. The motor will burn. Am I right? Let us say the elevator. Let us say I have a car. If there is an object in the opposite, I have to stop the car. Then this software inside the microcontroller will sense the distance and take the action and stop the motor. Those things have to be an embedded engineer's job. That is not the microcontroller is let's say there's a big thing that possibility and make it happen. The cars are manufactured by so many companies. But what is the job of a driver? Why only car is there? Why driver is required? Tell me now. Like that. You are in the driver's seat. You are going to use the microcontroller and do the specific functionality. That's why you are called embedded engineer. But the VLSI guy will build the microcontroller itself. Understand the difference? There's a big difference. You are going to use the car. That guy is going to build the car. You have to understand the totally different line. People ask me the difference between VLSI and what do you call embedded. VLSI is building the car, and embedded is driving the car. That's it.